In this paper, we present a method for pre-training a transformer model on a data source containing sequences. These sequences are simulated prompts that the model uses to learn. The specifics of the data source and the pre-training process are thoroughly detailed in the appendix of our paper. Our method involves performing loss minimization on the teacher forcing objective. This objective function, denoted as L, theta, is the squared loss applied to the outputs of the transformer model. We minimize this loss by adjusting the parameters, theta, of the transformer model. This process takes into account the randomness in the prompt and query. The transformer model we use has a specific architecture. It is a decoder model with 9.5 million parameters, 12 layers, 8 attention heads, and a 256-dimensional embedding space. These parameters were chosen based on previous work and have proven to be effective in our model. We construct training prompt sequences by randomly selecting a function class from a mixture distribution over base function classes. This mixture distribution combines examples generated from multiple distinct function families. The function classes used in the mixture distribution include dense linear functions, sparse linear functions, two-layer ReLU networks, and sinusoidal functions. The appendix of our paper provides a detailed explanation of how these base function classes are generated. Finally, we evaluate our model's performance on in-context learning and model selection between different function class families. In-context learning involves predicting the next token given a prompt sequence. We also test the model's generalization capabilities on functions that are not seen during pre-training and could plausibly be predicted. This allows us to assess how well our model can adapt to new, unseen data.